up here. Z times sigma. So the standard deviation is sigma. So it's Z times sigma plus mu. You want to do that for me quick?
Calculator. Yeah. 48.505.
Okay. And then what would I have to change to do it again?
You have to change what it's multiplied by. It's not negative 2.3. It's 3.1.
Mm-hmm. Which is 56.65 pounds. All right, go get a prize. How weird must it be to be a dog?
Wait, what is it 15 or 1.5? What did I miss?
Oh, it should have been 15 this whole time. Not 1.5. Well, whoops. So this one should have been, that still isn't right. 17.05
Yeah.
pounds. That makes more sense. And this one is 98.5 pounds. What do you think has a bigger standard deviation? If I had all dog breeds and I was weighting all the dog breeds, or, and let's say I was just adult dogs. So adult dogs, if I weighed them all, what do you think would have a standard deviation? Dogs or adult sheep?
Probably sheep.
I don't think so. I think dogs would be way higher.
Wait, what?
What's the question?
The question is, what would have the bigger standard deviation
Oh, yeah,
The
dogs.
weight? Wait,
Yeah.
deviation of what?
of the weight of dogs or the weight of sheep?
The weight of sheep
Dogs.
has a bigger one?
There's
Uh-huh.
more breeds of dogs and like Chihuahua.
Because it's more about variation, not about higher weight, right? Because sheep are generally heavier than dogs, that's for sure, but
Well, I was thinking like bull weight, like shorn versus unshorn,
Fat versus skinny.
I guess.
maybe. But I did take out all the young ones. I said adults. I don't know. I think the difference between a Saint Bernard and a Chihuahua are pretty significant.
Well, right. I don't know.
I can't think of another, actually, I don't think there is another, like, land animal that has that many diverse things within its species.
Monkeys. Oh, monkeys.
Nope.
They're like little ones. And there's like the gorilla.
Those are different species.
Oh, those are?
Yeah. Dogs are dogs. Like let's say I took a gorilla and like a little capuchin monkey or something, and I was like, make a baby. Like they couldn't because they're different species. But like a Chihuahua and a Saint Bernard could make a baby. Like, it sounds terrifying for the Chihuahua, but it is possible. They're both dogs.
Yeah.
And that baby would live and could have more babies, because you can have like two animals that are not the same species who mate and have a baby, but then the baby's usually infertile, like a mule. 'Cause mule is a donkey and a horse, I think, right?
Yes.
All right, number 4. Scores for the California Police Officer Standards and Training Test are normally distributed with a mean of 50 and a standard deviation of 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score an applicant can earn and still be eligible to be hired by the agency? Okay, this one we definitely need a picture for, so draw a bell curve on this one. Okay. So if I draw a bell curve, this 50 is in the middle. Top 10% is like over here, right? So what does it mean when it says, what's the lowest an applicant can earn and still be hired? Where is that on my picture?
The closest to 10.
The closest 10, so like here?
Like the closest.
Because I want, what's the lowest score they can get and still be hired?
Oh, that'd be on
Tell me, you're right.
the, like, right on the end.
Right on the edge of the green. So right, what we're trying to figure out is this line right here. What is the lowest score you can get but still hit the green? Right, still be hired. Okay, so what should I look to figure this out? First, I'm gonna need a z-score. So what should I look up in the middle of my table? You could, but it's the top, remember?
Negative. So, yeah, you can take the 10%.
But some of us are really struggling with that right now, so let's be nice.
90%?
So 90% we're looking up, because we're looking up the 90% right now. So when I look up 90%, if I look up 90%, the closest thing to that is 1.28. That's a z-score of 1.28. If you had looked up 10%, boys, if you had looked up 10%, you could have done that as long as you made sure it was positive and not negative. Okay? And then I'm going to use the formula we just figured out, which is x equals z times sigma plus mu. So x equals z, I just found out 1.28, times the standard deviation, which is 10, and plus the mean, which is 50. Now, you should have gotten 62.8, but usually that's not a score, right? Scores are usually whole numbers. So if the line, imagine this now in your head, if the line is 62.8, what score would get you into the green? 63. So the right answer for this problem is 63. Okay. A researcher tests the braking distance of several cars. The braking distance from 60 miles per hour to a complete stop on dry pavement is measured in feet. Braking distance of a sample of cars are normally distributed, have a mean of 129 and a standard deviation of 5.18. This is the kind of math you would do in a real life job like this. So it usually takes about 129 feet. What's the longest braking distance one of these cars can still be in the bottom 1%? All right, bottom 1%. And it's the longest distance, so we're looking for this line right here. Longest distance and still be in there. Okay.